All right, 7.6. Second to last video of the year. Now we are going to solve exponential and logarithmic equations. Your objective is students will be able to solve exponential and logarithmic equations. Wow, that's sounding like the title there. All right, a couple things you need to know. Or one thing you just need to know is this. There's two ways of solving exponential logarithmic equations, and this is one way, and this way is called getting a common, getting a common base. In other words, trying to get both bases to be the same. All right, and if you can, then if the bases are the same, that means you can just set the exponents equal and then solve. All right. So let's look at our first example, 9 and 27. Is there a number that if I can multiply by itself, how many times do you get 9? And is it the same base? I can multiply by itself to get 27. So here, 9, I'm going to rewrite this. Right? The reason why I did this is that I'm rewriting 9 and 27 as a different base. See, this is base 9, this is base 27. So I'm going to rewrite those. But I cannot forget there's still two of these exponents, so I'll keep them there. So I'm just going to rewrite 9 and 27. Well, 9 is 3 times 3, which is 3 squared. 27 is 3 times 3 times 3, and that's 3 cubed. So here the bases are the same. So what I'm going to do now here, I got exponent to an exponent, I'm going to multiply. Here I got to multiply, but I got to make sure I multiply it by everything. So 3 times x is 3x. 3 times -1 is -3. The bases are the same, so I can just drop the bases. So all I have is 4x equals 3x minus 3. This becomes a linear equation. So I'm going to subtract 3x from both sides. So I get x is equal to -3. And there's your answer. Now if you want, you can put -3 in there. 9 to the -6 equals 27. -3 minus 1 is -4. So if I did these on the calculator, 9 to -6 and 27 to -4, you'll get the same answer. So that's how you can check your answers. Let's look at another example. These type of problems should be easy to recognize. All right, I can get those the same base of 10. So I'm going to rewrite this as this way. All right. So 100 is 10 squared. 1,000 is 10 cubed. Right, so I'll multiply, so it's 10 to the 14x plus 2, and this is 10 to the 9x minus 6. Bases are the same, so I can cross those out. So I'm just left with exponents. All right, so subtract 9x here. So 14 minus 9, 4, 5, 6, 7, 8, 9 is 5x. Subtract 2 from both sides, and I get -8, so x is equal to -8/5. And there's your answer. Last example. This is a good one. Okay? So, again, I'm going to rewrite this like so. First thing I want to do is I notice here my base is a fraction. I want it to be a non-fraction. So in other words, I want to take the reciprocal of this. So it becomes 3. But since I took the reciprocal of it, it gives me a -1 exponent. All right, so this becomes 3 to the -1. All right. Now my question is this. Can I rewrite 81 as a base of 3? Yes, that is actually 3 times 3 times 3 times, that's 3 to the 4th. Right? If you don't know that by hand, whatever, just use a calculator. Just hit 3 times 3 and just keep doing that until you get what you're looking for. All right, so I multiply. Bases are the same, so I can drop the bases. So it'll be 12 minus 4x equals negative 5x plus 6. Let's see here, let's add 5x to both sides. So I get 12 plus x equals 6. Subtract 12. And there's your answer.